Hi, this video is going to be about using a can with liquid and finding the optimal surface area and volume. But first we need to measure the actual surface area and volume. So I have a can of crushed tomatoes. If you can see, it says that there's 28 ounces in this particular container. So that's going to be our units, and we're going to change those into cubic centimeters using a liquid measurement because what's in this can is more liquid than it is dry. We also need to measure the dimensions. For a cylinder, you need the radius and you need the height. So again, we can use a ruler or we can use grid paper. So for the grid paper, you're going to want to lay the can and determine what the radius is and then what the height would be. So by laying it down on the surface, you can do that. Now we have our measurements. We're going to use this to find the minimal surface area to actually contain that 28 ounces of pasta sauce. So you're going to see that we've taken the 28 ounces and multiplied it by the liquid conversion. It's a slightly different value than the dry conversion, and therefore our volume is now 828.072 cubic centimeters. I used the ruler to find my radius and my height. Originally the radius was 5 and the height was 12.5. So to find the surface area, I'm using this formula right here. Okay, since the can has both a top and a bottom, that's why there's 2 pi r squared plus h times 2 pi r. So that's literally the surface area of the side or the lateral surface area. So you can see here I did that and came up with a surface area of 554.778 square centimeters. Now I want to see if I can make that smaller using the constraint. So again, my constraint is the volume, and the volume of a cylinder is pi r squared h. Volume of 828.072. And I'm going to solve that for h. Now, just like the previous example, when I go to find the minimum surface area, I need to replace the 5 and the 12.5 with a variable. So I'm going to give you a second to try and figure out what that would be. So the formula I'm using is coming straight from the picture. I'm now going to replace h with this expression. And I will do some simplifying. So that's going to be my area formula, and that's what I'm going to try and minimize. So that means I need to find its derivative. So derivative is going to be 2 pi times derivative of r squared plus that number times the derivative of r to the negative first. I want to rewrite this a little bit. And this derivative is now what I'm going to try and find critical numbers for. So that means setting it equal to 0. trying to solve for R. I did something similar in the last problem by bringing the one fraction over. I can now cross multiply. And I get R cubed is equal to a decimal 131.792. If I take the cube root of that, I get that R is equal to 5.09 centimeters. Now again, they want to find the minimum surface area, so I need to find the height. And I'll use my constraint that I did before. And in this case, that height turns out to be 10.18 centimeters. So now it's the surface area. Well, the surface area of the new minimized can is going to be 2 pi times my radius squared plus 2 pi times my radius times my height. And that new surface area is 488.157 centimeters squared. That's the new. How does that compare to the old in this case? Well, the original wasn't that different. The original surface area was 554. So unlike the box, this cylinder had a surface area that was very close to the minimized surface area. And again, in your report, you might talk about why they were similar. Would you change the dimensions in order to make the surface area smaller, even though it's not a big difference, it's still different? And then if not, why wouldn't you? Defend the packaging of the current can.